talking about trusted types in front-end applications. So as Thomas said, I'm Philippe Ryck, and my name kind of looks a bit funky here because I have a very unfortunate name with some HTML attached at the end. And if you've been doing front-end development, if you've been doing any HTML and JavaScript, you kind of see what's going on here, right? This name contains a piece of HTML code, an image with a source none, doesn't exist, and an on-error handler with an alert dialog that pops up an alert dialog. That's your proof of concept cross-site scripting. By itself, that's data, not that malicious, not that harmful, unless it ever ends up in an HTML page. Like you can see here, a header, welcome Philippe Ryck, image source none, and of course, the red parts on the slide will pop up an alert dialog. Annoying, not very dangerous, but if everybody or anybody, like Thomas and their hacker buddies, if they tell you that they can pop up an alert dialog, you should be paying attention, because this means that they can execute code in your application on the machine of the user. So any user visiting the application, seeing this name, well, it's not going to say welcome Philippe Ryck, but it might say reviews by Philippe Ryck, image source none. But all of a sudden, the malicious code entered by the attacker ends up in the browser of a user, victimizing that user. Victimizing not through the alert dialog, but through whatever the attacker can think of. I mean, the attacker can write malicious code that executes in the application, in the front-end app. So anything a front-end developer can think of or can do, the attacker can do. And in reality, cross-site scripting vulnerabilities have severe consequences, and ironic consequences sometimes. Here's an app. I don't know the app myself, but they got in the news because of a cross-site scripting problem, so now I know about the app. And the app was supposed to keep your children safe. Like, you could monitor your child, and your child has like this GPS tracker, and you could see where your child is and keep track of your children, which may be useful in certain scenarios. And ironically, the app contained a cross-site scripting vulnerability that would allow an attacker to extract the information about your children's location, which is kind of the reverse of what you're trying to achieve when using an app like that. Just one example of how potent cross-site scripting really is. A second example is from Facebook. In this case, somebody found a cross-site scripting vulnerability in Facebook, and Facebook thought this was pretty serious and paid out $25,000 US in bug bounty. Just to give you an idea of, this is not a minor thing where you get like $500 for reporting this. This is like a serious vulnerability that can earn you serious money if you find them, which also means they are dangerous when they're exploited by the wrong people. That's the premise. Now that we got you good and scared about cross-site scripting, I have a promise to make to you. And what I'm going to explain here is trusted types. And trusted types, when used correctly, has the ability to fully eradicate DOM-based cross-site scripting in your application, in your entire application. And that's what we're going to achieve right here today. All right, before we do that, a small word about myself. I'm Philippe Ryck from Belgium, and I'm a security expert doing mainly training and consulting on specific security problems, preferably complex security problems, front-end security, API security, OAuth, OpenID Connect, things like that. I run my own company called Pragmatic Web Security, through which I organize trainings, courses, and consulting. I'm also a Google developer expert and an Auth0 ambassador, which are recognitions for my work I've been doing in the community, presentations like this one, resources, articles, blog posts, and things like that. Now, enough about me. Let's talk about this guy. Let's talk about Philippe Ryck with the unfortunate image source name. What happens when applications handle data like this? Well, let's look at one concrete example. If this data ends up in an Angular template, in Angular, you would use double curly braces to bind data variables into a template, and Angular knows that this is potentially dangerous. Angular knows, like, hold on, if I'm going to put stuff there, I got to make sure it's safe, otherwise the browser might get a bit confused and execute pieces of that data as code, and that wouldn't make any sense. So Angular and React, for that matter, and Vue and Ember, they all know about this, and the data will look like this when it ends up in a page. The data will have encoded characters, the dangerous parts, like the stuff that would start a new HTML tag, that's encoded to their non-dangerous counterparts. That's essentially these frameworks being aware of what they're doing and telling themselves, making themselves do this in a secure way. Awesome. So whenever you put that name in the page, in the default way, the standard way, there's no problem. And that's good. Until you run into a problem like this. Your customer would like to write pretty documents like this one. This is a CK editor document. I literally stole this from a CK editor website as an example. And it's basically HTML behind the scenes, right? You write this as a pretty document, but behind the scenes, you basically have headers and paragraphs and images and captions and so on and so on. And when you want to put this in the page with the curly braces in Angular or something similar in React and Ember and Vue, it's going to look like crap. Why? Because these frameworks will be like, hold on, this is dangerous. I'm going to encode all these characters, and you would see the actual underlying HTML being rendered on the page instead of the beautiful HTML being shown as we would expect, like the fully rendered version. No, you would see the characters, and that's not good. And that's why, that's why there's a secondary technique that you can use to put data in the page, and that's typically relying on the inner HTML property. The browser has a way to accept HTML data as input. You can tell the browser, like, here's a chunk of HTML, please render that for me in this portion of the page. You do that by setting the inner HTML on an element. All right, let's take a look at how that works in practice. And I'm going to use React as a first example here. In React, the property isn't called inner HTML. The property is called dangerously set inner HTML. We'll come back to that in a second. So you assign that data to that property, dangerously set inner HTML. That property will assign that to the browser's inner HTML sink, which is a dangerous sink for that matter. So it assigns that to the browser's inner HTML property in the DOM, which will trigger the HTML parser, which will make this document look pretty and add it to the page, basically. You happy, customer happy, your boss happy, everybody happy. Awesome. Until somebody comes around, that malicious user, and that malicious user is going to be like, let's see if we can mess around with that. And instead of a CK editor document, they give you Philippe Ryck image source none on error alert. Oh my God. And this is where things get a bit funky, because React calls this dangerously set inner HTML, but that's all they do. React is like, we don't really care. You use a dangerous function. That's on you, not on us. It will get assigned to the inner HTML property in the browser. It goes to the HTML parser. The HTML parser tries to load the image. Can't do that because the image doesn't exist. So it triggers an error. It sees like, oh, there's an unerror event handler. That's awesome. I'm going to take that string. That's JavaScript. I don't know what to do with JavaScript. I'm an HTML parser. So, hey, JavaScript engine, I got something for you. Can you execute this, please? And that code executes inside the application. That's essentially the process that the browser goes through to put that data in the page, and that's how a vulnerability like this will be triggered when you have a DOM-based cross-site scripting vulnerability. We call it DOM-based because it's assigning data into the DOM, and that triggers the execution of the code. Another name would be a client-side cross-site scripting vulnerability because the insertion happens in the browser at runtime. That's the problem here. All right. What's the solution? Well, in this case, in React applications, you are supposed to ensure that the data ends up in the page in a safe way. And you do that by using either escaping, as we talked about, which will look very ugly, or you do that with using sanitization as an alternative. And sanitization is the process where you take a piece of potentially dirty HTML, like that CK editor document, you run it through a sanitizer, which will remove everything it doesn't know to be safe. So it removes everything that's supposed to be dangerous. And it gives you a safe set of HTML in return. And that safe set is something you can assign into the page. In React, you do that like this. So that's the bad example on top. The dangerously set inner HTML in line 3 is very, very bad because doing that will cause a massive vulnerability in your application. How do you do it correctly? Well, you have to use a sanitizer, and a good sanitizer is DOM Purify. That's a JavaScript-based library. You can just include that in your project. And now you can call on DOM Purify. You tell it like, hey, I have a review to show. Can you sanitize that review, please? And DOM Purify will do what it does best, sanitize that piece of data. And then you can assign that into the application using the inner HTML attribute. It's still called dangerously, even though we made it safe. But yeah, that's not something I can change because that's inherent to the React framework. All right, so as a developer, you are somewhat responsible to make sure you do this on every HTML output. That's why they call it dangerous, but they still leave the actual work up to you as a developer. If you think that's bullcrap, I kind of agree. Sorry for the language. I kind of agree, because on the other side of the fence, you have Angular. And Angular is like, yeah, but why don't we do that automatically? I mean, why do we have to ask developers to make that safe? How often do you want to do this in an unsafe way? So Angular says like, yeah, we're going to do this by default. Whenever you bind something into the page with Angular, you have to use the square brackets and then inner HTML. Angular will automatically sanitize that data. Angular is going to be like, okay, I know what you want to do. I'm going to make that safe for you, and I will sanitize that data for you. And that's actually a better approach, but the end result is the same. You sanitize the data before you assign it into the page, and that's a safe way of building applications. All right. That doesn't sound like a big problem, right? I mean, why do we need something else if there is a perfectly fine solution? Well, because this is hard to do consistently. In fact, I just finished a 2-day Angular security workshop yesterday and the day before, where I talked about Angular and how Angular does things automatically, but also about a couple of ways to get things wrong. And as usual, people came back after like me talking about that an hour later, like, yeah, I looked at my code and I found an actual vulnerability. I found a place in our application where we didn't do that correctly. And that means that there's still a piece of data ending up in that dangerous sink, triggering the HTML parser, triggering JavaScript code to be executed, and resulting in malicious code execution. These things happen a lot more often than we would like to think they do in practice. In fact, funny story, a couple of years ago, Google released like a new YouTube feature, and within 5 minutes of its release, somebody found a cross-site scripting vulnerability. It's that common. Example from the React world, here's Signal Messenger. Their desktop version uses React to build the UI components, and they had a vulnerability where they forgot to sanitize the data. On the left, you can see the vulnerable line of code. The red one, dangerously set inner HTML with just the straight up data from a text message you're replying to, and that caused a vulnerability. That's the red arrow sidestepping the green sanitization box, creating a massive problem for your application. That's an honest mistake. There's other ways to do that. For example, in React, there's the option to use refs, and you can create a reference to a native DOM element. So this line 2 here creates a direct reference to a node in the DOM, which is reaching into the DOM without going through React, and that gives you the ability to call inner HTML directly. So you don't have to call dangerously set inner HTML from React. No, you can call inner HTML from the browser directly, assign something into the page, and create a cross-site scripting vulnerability. Again, here there's no sanitization, there's no escaping, there's no protection, meaning we have a red arrow that reaches the HTML parser that can result in JavaScript code execution. Not good, in case you're wondering. And before the Angular people are like, oh God, React, what are you doing? Angular has the same construct. It's called an element ref in Angular, and you use the viewchild constructor here. But basically what you do is you have the same issue. You get a native DOM element, you can access inner HTML directly, assign a value without protecting or ensuring that value is safe, and you have the same vulnerability. And I'm fairly confident, I haven't looked at all the JavaScript frameworks, but I'm fairly confident that all of them have a way to actually access native DOM elements, because we need that sometimes for legitimate features, like monitoring things on an element, not assigning stuff to inner HTML. Let me go to a first takeaway. The first takeaway in this presentation is that cross-site scripting in front-end applications is still a reality. Even though people like to think like, oh, but I'm using a framework, I'm probably protected because they heard something about automatic XSS defenses in these frameworks. That's absolutely not true. I can guarantee that many front-end applications, almost all of them, very likely still have a security vulnerability. It's going to be less than before. It's going to be harder to make them, or really hard to make them in an Angular world, but they're still going to be there. And that's the premise of this presentation. That's our starting point. Well, we're about halfway through, and we finally have a starting point. You're going to have a cross-site scripting vulnerability, whether you like it or not. That's the reality. And that brings us to trusted types. What if I told you that there's an easy way to prevent this problem? And that easy way is called trusted types. And you enable trusted types by sending a response header on the HTML page of your application. So whenever the browser loads your index.html, you can set a response header, content security policy, which is actually the header for a very elaborate security policy, but we don't care about any of that. All we care about is what you see on line 2, require trusted types for script. That's it. That tells the browser, look, I know that this assignments to inner HTML is pretty dangerous and pretty insane. So you know what? Why don't we not do that anymore? And the browser says like, oh yeah, that's a good idea. And the browser transforms this dangerous sync into a trusted type sync. Meaning, whenever you assign something to inner HTML or outer HTML or documented write or documented write-ln for that matter, the browser no longer accepts text-based information. The browser no longer accepts strings. Kind of relates back to what Thomas said about no types at all, and now we have a type system. Well, the browser basically enforces a type system and says like, hey, if you want to assign something to inner HTML, you better give me a trusted HTML type, nothing else. You want to assign a string? Bad luck for you, because I'm refusing to do that. That's what trusted types does. It transforms this insecure sync, this dangerous sync, into something that only accepts a value that is called trusted HTML, or of the type trusted HTML. And that is what trusted types really does in practice. I'm going to give you a bit more details as we go along. Trusted types comes from Google. It's built by Google people. Very smart Google people. Christoph Godowitz is the main driver behind trusted types. And they built that first internally as kind of a mechanism to solve this problem, because they found that static analysis was not enough. They found that their static analysis pipeline of their applications couldn't catch these DOM-based XSSs. So they said like, okay, let's build something into the platform that gives us the power to actually find and fix these problems for once and for all. And that's what trusted types does. For the record, to be very clear, trusted types does not impact regular DOM APIs. It only impacts unsafe assignments to something like inner HTML. If you want to create elements with DOM APIs, like on line 1, document.create element with a span, you want to set an attribute, you want to add some text content, and then insert it into the page, trusted types doesn't care about that. This is not dangerous behavior, because this is deliberate code written by a developer, not by an attacker. However, trusted types applies if you accept a long string from God knows where and try to render that into the page, like the CK editor document. If you try to render this, there's not going to be a call to document.create element h1. No, it's going to be like, here's a blob of HTML, you fix that. And that invokes a parser, and that is no longer possible when trusted types is enabled, at least not just possible. So how do you do that with trusted types enabled? Well, you can do that, but you have to ensure that this document that you're assigning to inner HTML is no longer a string, but a trusted type. So where do you get that trusted type from? Well, let's look at a React example. In a React application, you would have to sanitize that value. That was what we were required to do. Well, in this case, we still sanitize that value, but we tell the DOM purify sanitizer like, yeah, when you're done, can you please return this value as a trusted type? And DOM purify will be like, yeah, of course I can. And DOM purify will sanitize that string. It will transform it into a trusted HTML type and give it back to your application. And now you can assign this into the DOM to inner HTML, and the browser is like, hold on, inner HTML, what are you doing? Oh, it's a trusted HTML type. Yeah, that's good. That means you have jumped through a couple of hoops to ensure that this value is safe. Otherwise, it wouldn't have the trusted HTML type. So I'm assuming you jumped through the right hoops. I'm going to assign that into the DOM. And bam, there goes your CK editor document, and everybody's happy. Awesome, right? Not that difficult to enable. Good. What about Angular? Well, Angular, I might be biased. I like Angular. Angular is a little bit more awesome than React in this case, because Angular is like, oh yeah, let's do that by default. Since Angular 11 and 12, which is like about a year ago, Angular is like, oh yeah, we'll automatically, when we sanitize something, we'll automatically make it a trusted type. Awesome. So in Angular applications, all you need to do to enable trusted types is add the header on top, require trusted types for script, and you tell the browser like, oh yeah, by the way, everything created by this Angular trusted types policy, that's acceptable. And your code doesn't have to change. Your Angular code remains the same, because everything that Angular sanitizes by default is already marked as a trusted type out of the box. Pretty damn awesome, if you ask me. In React, it's a little bit more effort, but the principle is the same. We change the way the browser behaves, and because of that, our applications are forced to make things safe. Trusted types doesn't force anything. The only thing trusted types does is make you jump through those hoops. Trusted type says like, oh, you're giving me a string? Like, what the hell are you doing? You've been doing that for 10 years. I know you've been doing that for 10 years, but I don't really care. I want you to look at this and make sure that you do that in a safe way. And making sure you do it in a safe way could be, oh yeah, I'm feeding it to Drum Purify, so I'm doing the right thing. Okay, let's just mark it as trusted HTML in that case, and boom. You did the right thing. Trusted types is happy. The browser will render your HTML and good. And if you find a place where the browser says like, yeah, screw you, I'm not doing that, and you look at it and you're like, oh, good catch, because I actually forgot to sanitize this value, but you can now sanitize it and make your application more secure. So takeaway number 2, trusted types avoids unsafe DOM assignments. Basically, when you enable trusted types, you modify the default browser behavior. And because of that modification, the browser refuses the insecure usages of inner HTML, outer HTML, right-ln, and so on. Awesome. This must make you warm and fuzzy inside, right? I wish I could see Thomas and Stephanie now, because I'm pretty sure that they will be like, oh yeah, this is super awesome. Until you maybe look at this slide. It's like, who supports that? Oh, Chrome. And by definition, every other browser built on Chromium, like Edge, Opera, Brave, and so on. It's like, that's not too great. Like, what the hell is going on with IE? Well, we kind of know what's going on with IE, so let's not talk about that. But Firefox and Safari don't support this yet. And honestly, there's no timeline in which these browsers are aiming to support that in practice. So, have I been talking about an air castle here? Like, dangling a carrot in front of you and then taking it away. Like, you can't have this. Well, no, not really. This is what makes trusted types really awesome. It's only going to get better from this point on, by the way. Here's what happens in a Chrome browser. You're a developer or a hacker. You can also use this to find vulnerabilities, but I'm not going to talk about that. But you're a developer and you're using Chrome or Brave or whatever. I don't care. A browser that supports trusted types. And you find a piece of code, or you have a piece of code in your application that does something like this. It grabs a native DOM element, assigns a value to inner HTML, and potentially creates a cross-site scripting vulnerability. It's hiding in plain sight because it works as you expect until somebody gives you malicious data, which you are unlikely to do, but an attacker may do. However, trusted types doesn't care about the data. It doesn't care what you assign to it content-wise. It just says like, hey, developer, you cannot assign a string to inner HTML. What the hell are you doing? And you're going to be like, oh yeah, crap. That's indeed my mistake. Whoopsie. And you're going to rewrite your application either to use DOM Purify to sanitize the value or to use the Angular way to put this in the page, kind of depending on what you're doing. But nonetheless, you'll have to do something to fix this. Otherwise, this is not going to work with trusted types. And that's the process you go through. And because of trusted types in development mode, you learn how to improve the security of your application, because trusted types will call you out on insecure behavior. It will tell you like, no, we do it like this. You're like, oh yeah, okay, let's do it like this. And that's the true value here, because now you fix your application and you deploy it in production and somebody comes around and uses Firefox, and Firefox is like, I don't know what trusted types means. But it doesn't matter, because your application now looks like this. Your application contains secure code because you have fixed the problem by looking at it in development in Chrome with trusted types enabled. And now, all of a sudden, your application is more secure because of it. And that's absolutely awesome. That said, nothing prevents you from also deploying trusted types in production. You can deploy it and Chrome browsers will pick up on it. And for non-supporting browsers like Firefox and IE, if you really want to know, and Safari, there's polyfills available that offer the same APIs. So just by loading these polyfills, you can basically pull in trusted type support into those browsers as well. But trusted types already has major advantages if you only use it in development mode, but you can also use it in production. Takeaway number 3, if I'm not mistaken. Trusted types aims to improve the security of your application. Keep in mind, trusted types doesn't do anything on its own. Not yet, at least. I'm going to come to that in a second. Doesn't do anything on its own. It just forces you to look at these insecure usages of inner HTML and potentially fix them the right way. And that's essentially what trusted types does for you. Makes it absolutely awesome. So where does that leave us? That leaves us here, right? We have our data. We have found all the ways or all the different parts in our application where we use a dangerous sync, and we have fixed them. We have added escaping where necessary. We have added sanitization with dump purify or with Angular or whatever you're doing. Ember and Vue also require dump purify, by the way, because Angular is the only one doing sanitization by default. Awesome. Good job, developer. Star for you on GitHub. Until you realize that your Angular app, which with a few thousand lines of code, actually uses about 1 million lines of third-party code dependencies. Wait, 1 million versus a couple of thousand. Let's make the box a bit bigger. That's more representative. You have a whole ton of dependencies that do a lot of things in the application. And if you use one of these dependencies, like Bootstrap, to put data into the page, they can create a vulnerability. Bootstrap has documented usages of, for example, tooltips, where the wrong tooltip, a tooltip inserted by the attacker, is added to the page and triggers a cross-site scripting vulnerability, just like that, which is, in case you're wondering, not very good. So what's the point of having to secure our application if our dependencies might screw it up anyway? And this is going to be really awesome, by the way. Remember what Trusted Types does. Trusted Types changes the way the browser works. It basically removes the insecure use of inner HTML and forces everyone to use a secure way to assign data to inner HTML. So when your Bootstrap framework is trying to assign a tooltip in an insecure way, the browser will be like, what the hell are you doing? No, we don't do that. Go away. Good? Yeah, I think that's pretty good. But what did we do before? Before we actually looked at the code, we saw the problem and we fixed our code. So we can open up Bootstrap and try to edit the minimized JavaScript. I mean, that's not going to be fun. I can guarantee that. You can call the Bootstrap people or basically rant on GitHub like, hey, you've given me a free project with insecure code. Go fix it, please. And they're probably not going to listen. And you shouldn't do that, by the way. That's not a very nice way to deal with the open source community. And that's where the last part of this presentation comes in. Trusted Types offers a way to automatically secure every insecure assignment. And that allows you to fix your dependencies as well. You can write a default Trusted Types policy that applies in case somebody tries to assign text to a dangerous sync like inner HTML. The default policy can be used to transform that text into a safe value. And that code looks like this. You define a policy at the bottom. The Trusted Types API in the browser allows you to do create policy on line 5. And you call that policy default. That's a reserved name, default, which means if nothing else applies and you have text that's being assigned to a sync, just call this create HTML function. It will take text as input and will output a trusted HTML type and gives you the opportunity to apply a security function yourself. This is only in case of emergency or in case you want to protect code that you can't change. Otherwise, you should follow secure coding guidelines in Angular or React or Vue or Ember. In this case, we're calling dump purify. Note how we don't have to tell dump purify to return a trusted type. We can just return a sanitized value and the policy will make it a trusted type behind the scenes. But on line 7, we basically take that dangerous input, we transform it into a sanitized string as output, and we return that from the policy. So when Bootstrap assigns something insecure into the DOM, the browser is going to be like, hold on, no. Text to inner HTML, we don't do that. Oh, here's the default policy. Oh, default policy, make this secure. Yes, I'm done. Here we go. And that gets assigned to the page in a safe way, fixing the problem in your application. And this makes Trusted Types goes from awesome to super awesome. Word of warning, if you want to use this feature in production, you need the polyfills. You need the actual polyfills available in all browsers so that you can actually transform this into safe values. That's a very important caveat. Otherwise, either things are going to break or you might have vulnerabilities. And this latest example shows how Trusted Types is basically a browser-level security measure. it changes the browser. So every piece of code running on top of that will benefit from that protection. And having a default policy can enable automatic protection as well. And that's maybe the most important takeaway from this entire presentation. If you want to know more, like I said, Christoph Kadowitz from Google is the main author behind Trusted Types. They have done a lot of project conversions to Trusted Types. I think VS Code, Visual Studio Code, has been transformed to rely on Trusted Types for security. They're working, a whole bunch of Google products use it, of course, and they're working on a whole bunch of other projects to transform them to use Trusted Types. There's a website here, web.dev/trusted types, gives you a bit more information, a bit more context, a few examples, and so on, that you might find useful to look into. All right, that's it for me, basically. If you want to learn more about security, I have other security courses on my website, so you might want to check those out in the meantime. And with that, I want to thank you for being here. Thank you for listening. Well, at least if you're still here, but if you're hearing me now, then you made it till the end, so that's absolutely awesome. So thank you for being here. Connect with me on social media. I'm on Twitter with Philippe de Ryck, not the image source none version, and on LinkedIn as well. So always happy to connect with you. And if there's any questions for the live audience, it's my pleasure to take them right now.
Yes. So my heart is warm and fuzzy, indeed. Thanks, Philippe, for this great talk and for this great summary about trusted types. What surprised me also, I didn't look at the very details. I know the basics, but not the details that once you secure your application using trusted types, you're automatically protected, even though you're using a browser that doesn't support trusted types. And this is really awesome. This is my key takeaway of this talk. So thanks for this. We have a few questions on Slido. So I will start with the most upvoted question, and we work ourselves down until time's up. That's going to be 15:15. So the first question, or the most upvoted one, is how is Vue.js behaving compared to Angular and React?
Okay, I'm not a Vue expert, but I know enough about Vue to at least give some valid opinion. So Vue is closer to the React camp than to the Angular camp. So when you do default data output, it's always going to be escaped. I mean, every decent JavaScript framework will do that automatically, so that's good. The HTML output, there's a property called v-html. That's the Vue way of doing things. That is basically like React. It just outputs it directly. It's not called dangerous, so that's one strike. I mean, compared to React calls it dangerous. Vue is just like, yeah, whatever. And the documentation page says like, yeah, this is dangerous and you shouldn't do this, and so on. But it doesn't really do it automatically or even hint at you that you should avoid this property. So as for the element refs, I don't know the Vue way of doing that, but I'm fairly confident that there will be one way or another to actually grab native DOM elements, and that opens
yes,
up.
there is. I can confirm. I have a little Vue.js side project, so you can create references and just use inner HTML actually.
Yeah. All right. So that problem is right there. And then if you want to really dig deeper, if you want to assign URLs to anchor tags, for example, an href for an anchor tag, that's a common attack vulnerability or attack vector, because you can
JavaScript
URL. Yes. Yeah. Vue doesn't protect you against that either. The documentation says like, this is something you might want to cover, but there's no automatic protection, just like React for that matter.
Yeah. So Angular, of those three big frameworks, is actually, in terms of security, at least, this is what we can say, it is the best framework because it comes with an automatic sanitizer, which is really awesome, right?
Yes. When it comes to Angular, they do everything out of the box. They still offer ways to shoot yourself in the foot, but you at least have to do some effort to get there. But if you really want to, you can still do so.
Yeah. Okay, next question. Is server-side security validation better practice than front-end?
That's
not really related to this talk, but a more generic question.
Yeah. It's funny because I've been working on API security material, and I have like a whole chapter on never do security in the front end without doing it on the server as well. But here the story is a bit different because cross-site scripting is inherently a front-end problem when you're dealing with Angular and React and so on, because the server-side code never sees an HTML template. Not even when you do server-side rendering, it's still the Angular code that's responsible for creating the page and putting data in there. So the Angular code or the React code or the Vue code has to guarantee that it does that in a safe way. The server side cannot protect you against cross-site scripting in this scenario. So I would say server-side security is important, but in this case, the responsibility is a front-end responsibility, not a server-side responsibility.
Absolutely. That's why also when you look at the OWASP API security top 10, which is specific for the server side, cross-site scripting isn't in there because the server side doesn't have that problem. It's responsibility of the front-end part, right?
Yeah, it's not that visible though, because they added cross-site scripting with injection now in the new top 10.
Exactly.
So they're both called injection, but if you know, then you know. But I agree. Cross-site scripting is not an API problem. It's a front-end problem in this case.
Yeah.
Only exists, by the way, in web-based applications, because if you have a React Native app, there's no HTML, there's no JavaScript, and the whole problem goes away. So
Maybe more generically answered, I mean, you can have front-end side input validation as long as you have a server-side counterpart. It's good for usability, and you save a couple of round trips for server-side validation. Not speaking of trusted types and XSS, that might be the answer that this person was expecting. I don't know. So the next question is, when an attacker does a cross-site scripting attack, couldn't they just inject a trusted type object and the XSS would work again?
That's a good question. Generally speaking, no. So there's a couple of things going on. First of all, to inject a trusted types object, you can only create trusted types in JavaScript. So that means you would already have to achieve the execution of malicious JavaScript in the first place, which is likely not possible because of trusted types. So that's defense number one, basically. To create a trusted types policy, you would have to get script execution, which you can't get because of trusted types being applied correctly. The second thing is, I haven't talked about all the details, but you can lock this down. So you can specify in your content security policy, you can tell the browser, like, hey, you're only ever supposed to execute the policies with these names and nothing else. And once a policy is defined with that name by your application and somebody tries to create a second, less secure policy with the same name from a piece of malicious code, the browser will be like, yeah, no, I'm not going to allow you to override existing trusted types policies. So you can lock that down there. That's mainly intended to avoid third-party code that you include. Like if you include analytics from a less trusted provider and they're trying to circumvent your trusted types policy, you can lock that down by setting your CSP policy in a strict way. Website, I linked to details, a couple of those things, so you might want to look that up.
Yeah. That was my question, by the way. My plan was to push you off the rails, but I didn't manage. Sorry.
Yeah, I love the welcoming attitude that sec4dev has. Let's get this guy back until we can push him off the rails. Awesome.
Okay, so we have a couple more questions here, and we have more time. So let's keep discussing this topic. It's really interesting. Will my application break in non-supporting browsers if I use trusted types, or will I lose the extra layer of protection? I think we partly clarified that, but maybe summarize that answer in one or two sentences. So in non-supporting browsers, will it break?
Yeah, in a non-supporting browser, it doesn't create or doesn't enforce trusted types. So you would just end up with the same level of protection as you would have without using trusted types. That's one thing. The second thing is if you use DOM Purify or Angular, for example, they have a fall-through mechanism that if trusted types is not supported, that they'll just return a string after sanitizing that value. So your application is still doing the right thing. It's still going to work perfectly fine. If you rely on trusted types policies that you explicitly create in code, like trusted types.create policy, that's obviously going to fail in a non-supporting browser. And if you rely on that, then that failure might impact your application. So in that case, if you use the create policy feature of trusted types, you need that polyfill loaded in the browser. So you can circumvent that breakage by adding the polyfill, which will add those operations in a non-supporting browser and gives you everything you need to enable trusted types as well.
Mm-hmm. Okay, awesome. Next question, a very good one, I think. It kind of seems weird if you have to use a function like DOM Purify that you have to pull into your application to sanitize unsafe HTML, because it sounds a bit like that should be a native function of JavaScript. So is there a browser native way to take a string and sanitize it, or do I have to pull in an external library like DOM Purify?
That's an interesting question. Depends on the moment you're watching this video, I would say, because the talks are recorded. So today, February 24, 2022, there is no way to do this in the browser. You have to use DOM Purify. However, in the coming months, there is work going on an HTML sanitization API that comes to the browser natively. So Chrome and Firefox are working on that, and the idea is to offer this feature as a built-in API in the browser. So in the future, if you're watching this in the year 2023, hopefully we're not at war and we actually have an HTML sanitization API in the browser. So yeah, that's coming. And one of the things that is likely going to happen when it comes into the browser is that we'll see a default trusted types policy that uses that browser-based API to enable all of these features automatically, and that will probably help us protect our applications as well. So
yeah, because it could be DOM Purify, sanitizing HTML, parsing it, throwing out stuff, and then rebuilding HTML sounds like a complex task and sounds like a big library that we have to pull in.
Well, it's not actually, because it uses the browser's parser behind the scenes. So what DOM Purify actually does, it's pretty ingenious. It asks the browser, like, hey man, can you parse this HTML for me? And the browser's like, yeah, that's what I do. So of course. And it gets back a tree and it just walks a tree. So it's basically every element and attributes, like goes over it, maps it against a list of known safe stuff, like image, safe, on error, I don't know what that means, out. And at the end, it just has a tree that it can put back into a string-based HTML format, and we're good to go. So it's not a large library. It's actually very slim, very small. It relies on the browser, so it's very reliable as well. But yeah, it's a dependency you have to pull in. Absolutely.
Yeah. Mario Heinrich is doing a good job on this one. Also, next question regarding frameworks. Which frameworks are supporting trusted types natively and which are not?
Angular is supporting trusted types, which kind of makes sense. They're doing sanitization. So what they did in their sanitizer is like, hey, if you return this value and trusted types is there in the browser, just make this a trusted type, and everybody else is not.
Okay, so Angular being the only one. I find this particularly interesting because when you look back in history, Angular version 1 was where everybody poked on and said, you have XSS problems, and another XSS problem, and another vulnerable version. And but they really made a huge jump from major version 1 to version 2, where they introduced all those security mechanisms. And now, in terms of security, it is the most robust front-end framework, or SPA framework.
Yeah, I don't agree with that, by the way. It's an unfair characterization of AngularJS. So the issues that people talked about wasn't because the framework itself was insecure. It was because they did template parsing in the browser. So all the other ones did compilation. They compiled their templates at build time and then shipped JavaScript code to the browser, basically. And Angular supported template parsing in the browser, which would allow an attacker to insert template code into the page, which is basically like injecting PHP code in a PHP app, which is pretty bad. And that's what got them the bad reputation. And that's something that they did fix in Angular 2, of course. So in Angular 2, they said, like, yeah, screw this, we're doing template compilation as well. And that took care of a whole bunch of problems. Absolutely.
Yeah. Major overhaul at major version 2 here.
But sanitization has always been there, even in version 1. So just to make things clear.
Yeah, thanks. I mean, this is what we're discussing. All right, maybe last question. The DOM seems to be a mess. Can't we just start all over with dynamic browser languages and the DOM API?
Yeah, you're not wrong about that. Ask Microsoft. They tried to build a new browser and with Edge, and eventually they said, like, yeah, screw this. We're just going to use Chromium because we can't figure out how to get this right. Is it better to start over? I would like that to happen, but history has taught us that it's very unlikely to happen. As in, are you going to rewrite your entire application to use a new way of talking to the DOM? I don't think so. And it would be a commendable effort, but the adoption rate would be slow to impossible. You would have to maintain 2 DOM implementations, which is going to be a nightmare. So I think we're better off trying to fix issues that we have now in ways like trusted types than coming up with a full new mechanism. But who knows? I agree. If you're convinced that should work, then I would say go for it, and let's see where we end up.
Yeah. All right. So thank you very much, Philippe, for this awesome talk and this awesome discussion here at the end.